this for y, but you need to rewrite it to find the derivative. Oops, no, that's a 1/2, right? Okay, is everybody good on the rewrite? Okay, so now what I want to do is take the derivative of this. Do you see it's a chain rule?
Yeah.
Okay, do you see it? Did you find the outside? Okay, so it's going to be plus or minus times 1 times 1/2, so that would be 1/2, times leave the inside alone, take the power down by 1. So if I'm at 1/2 and I take the power down by 1, where am I at now? Negative 1/2, okay? Now I'm supposed to leave the inside alone, so there's my inside, but I also have to what? Take the derivative of the inside, which is, what is the derivative of 25 minus x squared? Negative 2x. And so what I get when I'm trying to find y prime here is plus, see if this makes sense, it's actually negative 2x over plus or minus 2 times 25 minus x squared. Let me make this the square root. This is really the square root of 25 minus x squared. Right? Because if you're talking about pluses or minuses, they can slip. Does that make sense? They can slip up and down when you have a fraction. Okay? So I have something like this. Do you see anything that cancels? The 2's. So this is basically negative x over the square root plus or minus of 25 minus x squared. I won't worry about the signs too much, but the truth with the signs is if I have negative over plus, it's going to be a negative. Negative over negative is going to be a positive. So in the end, really this is what I have. Right? Plus or minus. Okay? All right. Why would there be 2 possible derivatives? Does it make sense that there might be 2 possible derivatives in this picture? Yeah, let's look at this picture. If you had this picture, remember this is x squared. This circle here is x squared plus y squared equals 25. What's the center of this circle? 0, 0. Okay. What's the radius of this circle? 5. So this would be negative 5 here. This would be 5 here. And what I'd like to ask you to do is find the slope of the tangent line. What am I asking you to find? The slope of the tangent line, which is really the derivative. Find the derivative when x is 3. So if I go to where this is 3, okay, on the curve, so 3 is right there. The curve, actually, it's not a function, right? A circle is not a function. If I did the vertical line test and went through it, I don't hit just one line. Sometimes I hit 2 lines, right? So 2 points. So therefore, it doesn't pass the vertical line test. The circle is not a function. So what happens is I end up with 2 points for my x equals 3. At this point, I have one slope, which is y prime equals, let me recopy that, negative x over, probably, this is a negative slope, so it's probably over 25 minus x squared. And this slope here is going to be the opposite, negative x over negative 25 minus x squared. You guys see why there are 2 slopes? There are 2 slopes because they're actually 2 tangent lines, okay? So how would I get the slope of this tangent line? Everywhere there's an x, I would put in a what? A 3. So let me try it. This would be negative 3 over the square root of 25 minus 9, which is negative 3 over 4. Okay, so this slope is negative 3/4. What would be the slopes down here? What would I plug in for the x here? Also 3, right? X is 3. And so this is going to be negative 3 over negative the square root of 16, which this one's going to be positive, right? Positive 3 over 4. So there are my 2 slopes. One is 2 derivatives, so to speak, at 3. One is negative 3/4, and the other is positive 3/4. Okay, any questions about that? So what I'm going to do now, so that's your warm-up. You can hold on to it for a second because I want you to use it to compare. Okay, and maybe put this one in your notes because you'll probably see a problem like this again. Okay, both on your homework and possibly on your test. Okay, this was my problem. What if I didn't do explicit differentiation? What if I did implicit differentiation? And what implicit differentiation is I'm going to take the derivative without solving for the y. I'm going to do it inside, implicitly. Okay, it's going to be subtle. I'm not going to pull out the y. Okay, I won't call on you. I'm just going to do it subtly. Okay, and so the way you do that is this. You take the derivative of each term. So the derivative of x squared is 2x. You guys good with that? Okay, but I want you to think about this. When we said the derivative of x squared was 2x, we actually did a lot of math. We just didn't write it down. Because the derivative of x squared, okay, if you use the chain rule, okay, what you really did, or the power rule, what you really did was you said 2 times 1 is 2, carry down the inside, take the power on the outside down by 1, okay, leave the inside alone, the inside is x, and then take the derivative of x. What's the d dx of x? 1. So your answer here was 2x. And we didn't talk about all that, but that's essentially what we did here, okay? So when I do the next derivative, I want the derivative, the d dx of y squared, okay? So I'm going to have to do the same thing. This is really a power rule, okay? So 2 times 1 is 2. Leave the inside alone. Take the power down by 1. Okay, so 2 minus 1 is 1. Okay, again, we're supposed to leave the inside alone, so the inside has a y. And then you need to take the derivative, the d dx of your y. Okay, and the trick with taking the d dx of something with a y, okay, is that this does not cancel out to 1. Does that make sense? Okay, when you had the x's, this canceled out to 1. So you didn't talk about it. You didn't say dx dx. I mean, you could have said 2x times dx dx. You could have said that, but that's kind of silly, right? That's just 1. Leibniz notation looks like algebra. Dx divided by dx is 1. Okay, so we didn't talk about it. But when you take the derivative of y squared, it is 2y. Do you see the derivative of y squared is 2y? But you've got this extra dy dx. You have to multiply it by dy dx. Okay, that's implicit differentiation, because you're taking a derivative with respect to x, and your function has a y in it. Okay, before we took the derivative with respect to x, and we never had a y in any of the functions that we took the derivative of. All right, and then let's just go ahead and take the derivative of 25. What's the derivative of 25? 0. Okay, and there we are. We've implicitly taken the derivative of this, okay, and you agree with me that my goal is to find y prime, right? If I can find y prime, then that's my goal, right? Take the derivative. Do you see y prime anywhere in here?
Mm-hmm.
Do you see it?
Is it dy?
It's
Maybe.
dy dx. Yeah, it's tricky, okay? It is dy dx. So if I can solve for dy dx, I have found the derivative. So let me go ahead, and what I'm going to do is I'm going to subtract 2x from both sides. So that'll be 2y dy dx is equal to negative 2x, okay? Now when I solve for dy dx, do you see it's negative 2x divided by 2y? I can cancel out the 2's, so that's really negative x over y, okay? And this is what I get the derivative is. I want you to go back to your warm-up where you did explicit differentiation. Did you see that you had in your warm-up this answer? Yeah, I don't remember anymore. Is it x squared minus 25?
No, 25 minus x squared.
Oh, it's 25 minus x squared. Okay. How can this be the same, or are they not? Are they the same? Guys, if you come up here to the original problem and you solve for y, what's y equal to? Aren't they really the exact same things? It is actually the exact same thing, okay? Because this right here was your y, okay? So when you do implicit differentiation, be careful with this, you get a y in the answer. Does that make sense? When you do explicit differentiation, which is what you did for your warm-up, there are only x's in your answers, no y's. But they're really the same thing. They're really the same thing. Sometimes one is more useful than the other. You can actually do it either way. Sometimes one's more useful than the other. You just kind of pick, okay? All right, we're going to go one step further with this, Brant.
So would you still get 2 answers if you did the...
Both answers would be correct.
Okay.
Both answers would be correct. Okay. And then it just depends on what they're asking you. Okay. All right. I'm going to go one extra step. And what I'm going to ask you to tell me is, can you tell me the second derivative of x squared plus y squared equals 25? Can you please give me the second derivative? Okay, and this is on your homework. You need to be able to find the second derivative. Okay? And so at this point, can you guys go ahead and pass up your warm-ups? Hopefully you're working your notes now. Okay? You know that the first derivative, and I'm just going to work with the implicit form. Okay? You know that the first derivative is negative x over y. We've already figured that out. Okay? So do you agree that if I wanted to get the second derivative, then I would just take the derivative of the derivative? Do you agree with that? Okay. So let me show you this just to make sure you understand. What is the second derivative? The second derivative is taking the derivative of the derivative. And I want you to look at notation. If I take the derivative of something, do you agree it's a d dx?
Yes.
Right? Well, look at this. D dy, there's where your squared comes from. You have two d's.
Whoa.
Dx times dx, there's where your dx squared comes from. Okay? And that's why the Leibniz notation is so nice, because it works out algebraically. So the second derivative, it looks so funky, like why is the 2 here and the 2 here? It's because of this notation. Okay? Two d's, two dx's. All right? All right. So what I'm going to do is take the derivative of this. Okay? So this is going to be the second derivative is equal to, okay? And see if this makes any sense to you. Quotient rule. See it? Quotient rule. Okay, so here we go. It's the derivative of the first times the second minus the derivative of the second. But hold on. What's the derivative of y? It's 1 dy dx. Okay, so this is going to be 1 times dy dx, derivative of the first times the second minus the derivative of the second times the first. Okay, all over the bottom squared. Okay, I know what you're thinking. You're saying, hey, how come there's a dy dx here, but there's not a dy dx here? Why isn't there a dy dx here? And why isn't there a dy dx down here? Because it's just the second. It's just the bottom squared. You didn't take the derivative. Does that make sense? It's when you take the derivative that you get that chain rule thing going on, that you get the dy dx. Okay, so guys, this answer, do you agree, would be, did I do all that right? Hopefully my signs are right. This answer, I'm going to rewrite it just to make it a little bit neater, is that. You guys good with that? Okay, now I'm going to change my question up a little bit. I want the second derivative of x squared plus y squared equals 25 only in terms of x and y. And they'll ask you this on the AP test, and I think you might have it also on your homework tonight. I want the answer only in terms of x and y's. And so what I want to do is, I don't want this dy dx here. I want to change that in terms of x and y's. Do you have anything on your paper that can change a dy dx in terms of only x's and y's? Exactly. Okay? Right here, guys, dy dx is equal to negative x over y. So if they ever ask you to do that, which they will, okay, all you do is you replace that dy dx with negative x over y. And at this point, it's no longer a calculus problem. It is basically an algebra problem. And I want to work out this algebra problem with you, because a lot of students have trouble with the algebra. You're really good at the calculus. Sadly enough, it's the algebra that's giving you problems, okay? Do you agree that x times negative x over y is actually negative x squared over y, right? Because multiplying fractions, it's no problem. Top times the top, bottom times the bottom, right? Okay, so this was really x over 1, okay? All right, so right here, I want to get rid of the fraction over the fraction. So what do I need to do to the top? How do you add fractions? Common denominator. So how do I get a y on the bottom of this one?
Multiply it by y over y.
Okay, you guys good with that? Multiply it by y over y. So this is going to be y squared over y now, or negative y squared over y. Okay, so this will be negative y squared minus x squared, common denominator is y on the top, all over a y squared on the bottom. Okay, and why is this useful? Because if I can get it to just one fraction, then I can do dividing fractions easy as pie, flip the second, and multiply. Remember, the second was really y squared over 1. All right, and so when I multiply this, what I get is negative y minus x squared. Oh no, did I lose my y squared here? It's negative y squared, right? Yeah, negative y squared minus x squared over y to the cube. Okay, and that will be my answer for the second derivative in terms of x's and y's. When you guys do your homework tonight and you check your work, some of you guys, instead of this answer, you're going to get this answer. Everywhere you have a positive, it's going to turn to negative, and everywhere you have a negative, it's going to turn to positive. And that is absolutely also correct. Are you guys cool with that? Okay, because it's really just multiplying by negative 1 over negative 1. All right, so it's absolutely correct. So when you guys check your answers and every single term is a negative answer of mine, then you're still correct. Okay, how are you guys feeling?
Pretty okay.
Good? Okay, we're going to do a little bit more practice on implicit differentiation. That was how to take the second derivative. Okay, so I've got that slide there. Let's go ahead and do some practice on implicit differentiation. Okay, and then we'll do some homework problems too if we have time. Okay, let's look at this problem right here. Okay, and I gotta warn you guys, implicit differentiation is super easy when you get the hang of it, just like derivatives. It's super easy, but it takes a while to get the hang of it. All right, let's go. What I want to do is find dy dx, okay? But to find dy dx, I need to pull out the y. Okay? I need to solve for y. Do you see it's impossible to solve for y here? Okay, I mean, it's possible, but you might die. Okay, so you really just want to just do implicit differentiation. It's a lot easier, okay, and it works. All right? Okay, so what I'm going to do is I'm going to take the derivative of each term. So I thought, let me do it in a different color. I thought I had to just take the derivative of one thing, but oh boy, I get to take the derivative of 4. Oh boy, okay?
Yes.
All right, so what I'm going to do is, do you guys see when I take the derivative of this first term, do you see what rule I'm going to have to use? Product rule. Okay, so let's go for it. The derivative of the first times the second plus the derivative of y, which is 1, but it's times dy dx, times the first. Derivative of the first times the second plus derivative of the second times the first. Okay, do you see why I have a dy dx there? Do you see why I don't have a dy dx here? Okay, because I didn't take the derivative of anything with a y. All right, let's go to the second term. The second term is the derivative of negative 2y cubed. What's that going to be? Negative 6y, right? But what do I need, guys? dy dx. It's just a multiplication by dy dx. All right, third term. What's the derivative of 4y squared? Plus 8y. But do you need a dy? Did I do it wrong?
Do you need a square?
Oh, I absolutely do. Thank you. Appreciate that. Okay, negative 6y squared. Good. And then times dy dx. What's the derivative of plus 4y squared? 8y. Do I need a dy dx? Yes, because I took a derivative with respect to x, but the function had a y in it, so I need a dy dx. And that's just a multiplication, multiplying by dy dx. On the right side, what's the derivative of 2 cosine x? Negative 2 sine x times dx dx, right? But that's just 1. All right, you guys good with that? Okay, so what I'm going to do is I'm trying to find dy dx. And my dy dx are here. They're implicit in here. Okay, so what I do is I highlight all of them, and I sit back and I think about how I can solve for dy dx here. Is it solvable?
Yeah.
Yes. Solving for the y wasn't solvable, but solving for the dy dx was definitely solvable. You do have to do a little bit of manipulation. You're going to have to subtract both sides by 2xy. Are you guys good with that? So subtract both sides by 2xy. Now, how the heck, guys, am I going to pull this dy dx out? Do you see it's just factoring? Is everybody okay with that? Once you move that 2x y out of the way, you subtracted it, then inside here, this just becomes a factoring. Okay, so this is equal to negative 2 sine x minus 2xy. And at this point, how can I isolate this dy dx? Divide both sides by this entire giant quantity. Okay, all over. So this is going to be x squared minus 6y squared plus 8y. And there's my derivative. Isn't that nice? Okay, so once again, guys, I'm not used to it, but now I'm going to have y's in my answers. Okay, and what that means is if it says, hey, find the derivative, and they tell you find the derivative at point x equals 3, okay, then not only will you have to find, will you plug in everywhere there's an x, you put in a 3, but you also have to go find your y. Does that make sense? When x is equal to 3, what is y equal to? And then plug in the y also. Does that make sense to figure out your derivative? Now you need to know both x and y to figure out your derivatives, where before you only needed to know your x. Okay? Guys, how do you find your y though? If on my problem I only gave you the x, how do you find what y is in that function? You go plug it back into this function, okay, and solve for y. This one's not solvable, but other ones that you have will be solvable, okay, and you go solve for your y. All right, let's go do another one. Here we go. Let's do this one. Okay, so your goal is to find the derivative of y. Find the derivative of y. So what you really want to do is pull out all your y's. Okay, pull out all your y's and solve for y. You could do it here, but by the time you get to the right side, do you see you cannot isolate this y? You could try really hard, okay? But with these y's involved, you can't isolate the y. So you're going to have to just resign yourself to implicit differentiation. Okay, it's not always harder. Sometimes implicit differentiation is easier. Like our warm-up, it was actually easier on our warm-up. Okay, so let's go ahead and implicitly take the derivative of both sides. You thought you just had 3 problems to do, but oh boy, you get to do 4. Or actually, you thought you had to do 1, but oh boy, you get to do 4. Okay, so here we go. Let's just take the first term. What's the derivative of x squared y? 2x, derivative of the first times the second, plus derivative of the second times the first. Did you get 2xy plus dy dx times x squared? Very good. Let's move on to the next term. What's the derivative of negative 2y? Negative 2 dy dx. Did you get that term? Move on to the next term. What's the derivative of 5x cubed? 15x squared. Dy dx? No, dx dx, right? But dx dx is really just 1. Good. What's the derivative? Okay, let me write this down. What's the derivative of sine u? That's cosine u du dx. But guys, now I have a y. Do you agree? So everywhere there's a u, put in a y. Put in a y. Okay? And do you see I really just copied this right into the right side? Okay? So this is actually cosine y times dy dx. Okay, so guys, the formula always works, and that's why it's so nice to memorize the formula. It always works. Okay, and it takes that implicit differentiation for you, because there really is a chain rule going on in here. All right, what's my next step? Yeah, add up all my what? My dy dx's. Okay, everything that's a dy dx, I'm going to pull to the left side. Everything that's not, I'm going to pull to the right side. So do you see this 2xy? That's moving to the right. Do you see this dy dx over here on the right side? It's moving to the left. All right, so let's go ahead and rearrange all of our terms. Any idea what to do after I pull all my dy dx's to the left? Factor it out. Okay, so I'm going to factor out my dy dx. Okay, and what's my goal again? Solve for dy dx, find dy dx, And so do you see at this point it is really just dividing both sides by whatever you factored out. And there is my answer. And if every single positive turns to a negative, and every single negative turns to a positive, you also have the right answer. Okay? You guys good on this problem? Not too bad, right? Okay, you guys want to do something bad? Yeah, let's do a bad one. Okay, let's do this one. There's something like this on your test. There's at least two implicit differentiations on your test on Monday, and at least one with a second derivative. Okay, so make sure you can do the second derivative too. And that's what we did for the warm-up. Okay, but let's look at this problem. This one's actually not too bad. What students have trouble with, though, is when there's a negative sign right here, they have trouble on what to do. And I want to ask you guys if you can do this for me. If you can just include the negative into your, if you're doing product rule, include it into your first. Because when you don't include it into your first, okay, so what students do is they don't include it in their first. What happens is after they do the product rule here, they forget to distribute the negative. Does that make sense? Because there's a plus in between with the product rule, and you get your negatives all wrong, okay? So what I would really strongly suggest is just including it in your first, and then all the math works out. Okay, so we're going to do find dy dx here, okay? The thing is, I'm trying to solve for y, okay? I'm breaking out in hives, so I realize I think I need to do implicit differentiation. Okay, so what I'm going to do is take the derivative of y cubed, which is 3y squared. Dy dx? Yes. Okay, so dy dx. Okay, next term, 2y. Dy dx? Yes. Dy dx. Okay, next term, minus 5. Dy dx? Yes, there was a y in there, so dy dx. Okay, next term, negative 2x. Dy dx? No. Dx dx, right? But dx dx is just 1. All right, next term, put an equal sign, so carry down your equal sign. Do you see product rule here, guys? So here we go. It's going to be the derivative of the first, which is negative 4, right, times the second, which is y, plus the derivative of the second, which is dy dx, times the first, which is negative 4x. All right? So then from here, guys, you do exactly what you always did, you did on the other problems, which was you isolate what? Dy dx. Okay, so try to figure out how to isolate all your dy dx's. Any term that doesn't have a dy dx, so there are two of them, move them to the right or keep them on the right. Any terms that does have a dy dx, move it to the left. Okay, factor out your dy dx. And if I did it right, you should get something that looks like this. 3y squared plus 2y minus 5 plus 4x. Did you get that? That's going to be your denominator. Okay, so then your goal is to actually solve for dy dx. So what do you do to both sides? Divide, right? Divide by this giant factor that you have in front of the dy dx. And hopefully all my signs are right. If you see something wrong, let me know. But that's my final answer. And again, if every sign of yours is opposite of my sign, then you still have the right answer. Okay? All right. Fun? Okay, let's go to your homework, guys. Let's look at number 3 on your homework. Let's do that one together. Okay, number 3 on your homework looks like this. X plus tangent xy is equal to 0. Okay? What you want to do is pull out that y. Possible? No. Okay? So what you're going to do is say, all right, I'm going to just do implicit differentiations. And implicit differentiation says I take the d dx of both sides. Do you see on the left that it's really just taking the derivative of two different functions and just putting a plus sign in the middle? Okay? What's the derivative of x? 1. Okay, let me write this though. Students get confused with this step. What's the derivative of tan u? Remember the formula. Secant squared u times du dx. What's my u in this problem? Okay, so that means everywhere there's a u here, I'm going to replace it with xy. Do you agree with that?
Yes.
So let me just copy everything I have here on the right up here. So this is secant squared xy times the derivative of xy. So does everybody see how I got this derivative of tangent xy? Okay? And then on the right side, I'm going to carry down my equal sign. And what's the derivative of 0? 0. Okay, so let's take a look at what I have. The answer is 1 plus secant squared xy times, okay, make sure you understand, it's times this entire quantity here, whatever the derivative of xy is, and that's equal to 0. What's the next step I'm going to have to do? Take the derivative again. Does that make sense? It's an implicit differentiation, right? So I need the derivative of xy, okay? So let me rewrite what I have. I have 1 plus secant squared xy. I need to multiply that by the derivative of xy. Do you see product rule in here? Okay, so here we go. The derivative of the first times the second plus the derivative of the second times the first. And that's equal to 0. Okay, once again, I can't lose sight of my goal. What was my goal? What's my goal here? To solve for dy dx. So guys, you're done with the calculus. You're good? Your calculus is done. At this point, it's just a bad algebra 2 problem, basically. Maybe even algebra 1. How do you solve for dy dx here? Any idea? How do you isolate that thing?
Subtract 1.
Okay, let's start by subtracting 1 on both sides. Okay. Divide by secant squared xy. Do you see that these are all just factors here? This is a factor and the red is a factor. So what you do is you'd say y plus dy dx times x is equal to -1 divided by secant squared xy. All right, still working on it though. Still trying to isolate this dy dx. What's your next smart idea? Subtract y on both sides. Okay, and then finally, what do I need to do? Divide by x. So it'll be -1 over x secant squared xy minus y over x. What I'm really doing is I'm multiplying by 1 over x on both sides, if that makes any sense. Dividing by x is multiplying by 1 over x. Okay, and that is my answer for number 3. I want you guys also now to look at number 8. Okay, if you look at number 8, I want you to kind of try to understand the problem here. Number 8 says you've got this parabola. Do you guys recognize that it's a parabola? Y squared equals 4 plus x. You've got this parabola, y squared equals 4 plus x. Now, what does this parabola look like? It's been a long time since I've done parabolas, but if I plug in, let's see, if I plug in y as 0, so if I'm trying to find the x-intercept, and I plug in y as 0, then x is going to be -4, right? So 4 plus x. So x equals -4. So at -4, -4, 0, I'm going to have a point here, -4, 0. Okay? And if I tried to find the y-intercept, that would make my x equals 0, right? To find the y-intercept, you make your x equals 0. So y squared equals 4 plus 0. So y is going to be plus or minus 2. So that means if x is 0, y is 2, or -2. So what I have is a 2 here and a -2 here. Okay, and it does end up, I think, you guys can make sure I'm right, but it's some sort of parabola that's sideways. I mean, how do I know it's a sideways parabola? Because y equals x squared is a happy sad parabola, right? Y equals x squared. But when it's y squared equals x, you know, it turns to like y scared. Look left and right. So it's a left and right parabola. Get it? Okay, I think you got it. Okay, so this is your parabola. And you actually don't have to draw this thing to do this problem, but it's actually just helpful to see what's going on here. I've got this parabola, and it says there's a point A and B. A is point -4, 0 right there. B is 0.02, which is actually right there, and there's a chord joining them. So let me draw this chord. There's a chord joining them. Do you guys know what a chord is?
Yeah.
Okay, me neither. But it says join them together, so just join them together. Okay, and it says find the xy coordinates of the point on the curve. So on the red parabola, find the point where your tangent line is going to be parallel to this chord. Okay, at what point is your tangent line going to be parallel to this chord? So I can kind of tell maybe this point right here. Does that make sense? At what point, if I did a tangent line on this curve, that tangent line is going to be parallel. Is everybody good with that? Okay, so what do I know about this problem? I know the function is y squared, y squared is equal to 4 plus x, right? I know that the slope of this, if these two lines are parallel, what do I know about the slope of this? Okay, so what's the slope of this one? Can you calculate that for me? Remember, this is 0.20. This is no, this point is not 20. This point is 0.2. This point is -4.0. Can you tell me the slope of that chord?
1/2.
Is it 1/2? Okay, if this slope is 1/2, then what's this slope?
1/2.
Okay, if this slope is 1/2 and this is a tangent line, okay, mine's too late. Annika's way before me. Okay, so if this is the slope of the tangent line, what do I know about this? The derivative of this function right here at this point, right? The derivative at this point is going to be, if I could find dy dx, right? That's going to be 1/2. Do you agree with that? At this point, okay? Is the derivative at every point going to be 1/2? No, only the derivative right here is going to be 1/2. At the derivative of this point, so let me call this point, xy. Whatever this xy is, that derivative right there will be 1/2. All right. So what I know is if I take this derivative, so let me find the derivative. You could solve for y, but it's way easier to do implicit differentiation. What do I mean by implicit differentiation? d dx, okay? The derivative of y squared, do you agree that's 2y? Do I need a dy dx? Yes. 2y dy dx is equal to the derivative of 4, which is 0. Please do not tell me the derivative of 4 is 1. I get that on the test all the time. The derivative of 4 is 0. What's the derivative of x? 1. So you do see dy dx is actually 1 over 2y. Okay? But for this point right here, for just this point right here, what's the derivative here? Just for that point, what's the slope of the tangent line there? 1/2. Now, is it 1/2 for every single point? No, it's just 1/2 for this point. So guys, do you see that at this point, I can actually find the y at this point? Because what I have is 1/2 is equal to 1 over 2y, okay? And so if the tops are the same, if 1 is equal to 1, then that means 2 is equal to 2y. You could also cross multiply and get this. If you have an equal sign, if you have one fraction on the left, one fraction on the right, and an equal sign in the middle, then you could cross multiply. And so that means 2 is equal to 2y. So what's my y equal to? 1. So it means at this point, my y value is 1. Okay, what's going to be the x value at this point? How do I find the x value? Yeah, you just plug in, because remember it's on the parabola. Okay, so I'm going to let you do that. You can do something, okay? I'm going to let you do that. But make sure you understand how to do this worksheet. How are you guys feeling?
Great.
Good, okay. So your worksheet, guys, is your homework, front and back. I'll put some of the harder problems online, and so you guys can check your solutions. And hopefully it doesn't feel too bad, but it'll give you some good practice.
When you say front back, you mean like the whole